Now we're really close to the finish line. I know today is quite a long day, but just bear in there. You're going to get there really, really soon. So the last part of our Caesar cipher just has 3 to-dos. One is we need to import and print the logo from this file art.py. And then we have to figure out, well, what happens if the user enters a number or space? So if you take a look at the final demo and we were to write a message, say hello, and then we add some numbers or some symbols, we don't want those to be lost when we encode the message, right? So what we want instead is we only want to encode the alphabetical letters. And then for anything that is not within the alphabet, we just keep it as it is and add it to the final encoded result. This way we can encode and decode and keep any of these characters the user types in. And then finally, we need a way for our program to rerun once the user is done with encoding or decoding. So that way, we ask them, type yes if you want to go again, otherwise type no. And if they type yes, then they get to encode or decode again. And once they're actually done, then they could type no, and the program just says goodbye, like a good little robot. So those are the 3 to-dos. Have a look in the description box, have a look at the hints if you need them, and go ahead and pause the video and complete the final part of the Caesar Cipher project. Okay, hopefully it was straightforward and you're just here to check the solution. If not, don't worry, I'm going to walk through everything and explain everything anyways, so hopefully it'll be a lot more clear afterwards. So to-do 1 is pretty simple. All we need to do is import the module art and then just simply print art.logo, which is the name that we've got in here. That's the name of the variable, and that's going to print out that Caesar Cipher logo with ASCII art every time we start our program. Now you can also do the previous from import, but this is also clear enough as well. Now to do number 2, we need to figure out what to do if the user enters a number or symbol or space, and how can we keep hold of it when they actually type that in. So let's think about where we would make that differentiation. Every time we loop through each of the letters, if that letter that we're looping through from the original text happens to be not something that exists in this list of alphabet, then it's probably a symbol or a number or something that we can't shift very easily. So then we probably want to bypass the rest of this and do something separate. So what we can do is we can say if the letter is not in the alphabet list, then in that case, all we're going to do is simply take the output text plus equals the current letter. And this will add whatever letter it is that we need to skip into the output text as its original format. But then we can have an else statement and have the rest of this carry out if this is not the case, which means the letter is in the alphabet and we can in fact shift it. Now another way that we could do this is we could add a bunch of symbols and numbers to our alphabet list, and instead of calling it alphabet, call it something else, and that way we can be more inclusive. But it's quite hard to include all of the symbols and all of the numbers, and just to keep it simple for this practice exercise, this is probably the most straightforward solution. So now we're on to do number 3. Can you figure out a way to restart the Cipher program? So as previous, the way that we need to do this is to use a while loop. So if we have some sort of variable, let's call it should continue, and we set it to true because normally while the program is going, it should in fact continue asking the user, do you want to go again? Do you want to go again? But sometimes the user will say no. So let's go ahead and create a while loop that checks for this variable. And if it is the case, then we're going to keep running all of these inputs, asking them direction, text, shift, and also running our Cipher function. But then at the end of all of that, once we've given them the encoded or decoded text and that Cipher function has come to an end, then the next thing we're going to do is we're going to check with them whether if they want to go again. So I'm going to copy this message and add it into an input. So in this input, I'm going to go ahead and change it to .lower to make sure that we've got the whatever it is they type, capital or no capital, set to the same thing so that we can check it more easily. And I'm also just going to add a \n so that our cursor goes on to the next line when they do have to type, so that it's cursor here rather than cursor here. Now, finally, I'm going to save that input into a variable called restart. And now we can check the value of that restart. If restart is equal to no, well, in that case, we can change our should continue to false, and then we can print goodbye. And if the restart is any other value, so yes or capital yes or whichever, then this if statement is skipped and our while loop loops back up from the start. So that is how we can make sure that our code continues asking the user for a message and their encoding or decoding, and it will continue forever until they basically say no. Now, if you've been following my code all along, I want you to try and test your code right now repeatedly and see if you can spot a crucial bug. Now, it relates to this Cipher function, and I want you to see if you can, through testing, figure out what is wrong and solve the issue. So pause the video now. So did you manage to find the problem? Here, let me show you. So if I go ahead and start encoding, and we decide to type A and B, and then type the shift to go up by 2. So that becomes CD, which is great. So let's go again, and let's now type decode. And again, use the previous ciphertext, which is CD. And if we take our ciphertext and shift it down by 2, we should expect AB, which is our original message, which we encoded up here. But instead we get AF. So what is going on? Well, if you debug, either using the debugger or your own knowledge, you'll find that this line here is the culprit. We're determining the shift amount by shifting it back to the negative, and that's what happens when we do -1. But this is inside the for loop, which means that it's going to happen and flip every single time the for loop runs. So in order to fix this, what we need to do is just to take it out of the for loop and then put it above the for loop. And now if we retest, you'll see we've managed to solve that problem. So going up works and going down also works. So that is all there is to it, to this 3-part Cipher project. And of course, as always with all of these projects, feel free to add modifications, tackle any edge cases. There might be things that I haven't thought of that you've thought of. There might be improvements you want to make. The program is yours, so you can do whatever it is you want to do to improve it. And hopefully in the process, you've managed to solidify and revise some of the topics that we've learned in today and previous lessons. And if it was really, really hard, then that's a good thing. That means you really struggled and you're building those programming muscles, right? There's no point going to the gym and lifting 1 kilogram weights. It's not going to make you very muscular. We got to push ourselves, and this is okay. So I hope you had fun with me today, and I look forward to seeing you tomorrow.